and then like controlling stimulation to boost performance while you're on the bike. So it's quite a simple problem. You can identify muscle activity through different stages of the pedal cycle quite easily, and you can tell when you should be stimulating muscles. So yeah, like the sort of simulation we've done of all of that works quite well, but sort of moving to an actual garment where it's working with an actual person been quite difficult, and I didn't realize how much would go into the clothing manufacturing. It's super technical and don't really know anything about it. So I've got a clothing designer that I'm working with, but yeah, it's really difficult.
Yeah.
I might be able to help you there, Devon.
Oh yeah. What's your background?
Is clothing. So
okay.
And my area is I'm at WSA, so I'm also with No Kai as well. But I particularly my interest is adaptive clothing, and but also integrated electronics in clothing. So I know manufacturers and also various clothing brands that are working on those kind, integrated electronics in clothing as well.
All right. Okay. So I'll just make a note quickly.
Yeah.
For just to chip in there, is there sort of any interest in exploring the mechanics of those materials a bit more, and how relevant are they for the applications? Because obviously you get all kinds of stretches in different directions depending on how you put your fibers, and presumably the electronics can be stretched to a certain degree, but
there's a huge amount of interest in that because the technology has to be reliable. I think there are lots of examples of integrating electronics and sensors on clothing, almost from a hobbyist point of view, and they work, but they certainly can't survive a machine wash cycle, for example, which is a really nice sort of measure of how mechanically robust your technology is. So yeah, there's a huge amount of interest, be it the printed films and protecting those so they can withstand bending and a certain amount of stretch, or ways of incorporating electronics that again can withstand all these forces. Yeah, so we have a lab set up with a huge variety of tests, from stretching, bending cycles, etc., abrasion. We test for all these things. And ultimately put it in a washing machine, see if it withstands 50 cycles, and if it can withstand 50 cycles with clothing, etc., then you've got a really good indication that it's robust.
Okay, cool. Yeah. So for the other application, it's a little bit of a side step maybe, but something I've seen maybe for Charlie, that where people in a sort of design fashion environment have thought about sort of 3D scanning of people and then sort of triangulating the surfaces of their body to make the clothing fit exactly to their body, which would also minimize the strains, because from Devon's example, I can see a cyclist with very big muscles pumping all the way that you can get extreme deformations there just by having a bit of Lycra on somebody's muscles, and sort of making them fit better in the first place could be a way to sort of minimize those initial strains maybe and those stretches. But
there is a lot of work on 3D scanning, body scanning. So, and there is equipment out there. Some of it is a little bit kitsch, but it's still being developed. But also there's a lot of work that has been done looking at the construction of fabric, so fabric construction, and now also a lot of the fiber organizations are looking at stretch alternatives as well. This is also because of sustainability issues within our industry, and looking for non-polymer and non-petroleum based stretch yarns and filaments. And some of the technicalities, some of these new developments that are happening are actually quite interesting, because they could have more medical applications, and they also could be developed more with integrated sensors possibly. So that, I think that is an area that working with these fiber producers and developers could be really interesting, and also working together with 3D printing as well. So that, you know, that sort of like combination. I don't know if you're doing anything like that, Stephen, at all.
No, not really. Well, we have used the scanning for creating very simple textiles, so gloves, for example, and getting a good fit for certain applications, but nothing for the full body or anything like that. So, yeah.
Can I just introduce myself to the group? Can you hear me?
Yep.
Yeah. So my name's Margaret Macaulay. I'm a nurse. I work in the Bladder and Bowel Management Research Group at the university, and we are really interested in incontinence. So helping people to manage incontinence. So we work on evaluation of existing technologies and developing new ones, including products. And the person that leads the group, unfortunately she's not with us, Mandy Fader. She and I both worked for many years with at medical physics and bioengineering at UCL with Alan Cottington, who's done a lot of materials development for felts. But this is an area where there's a lot of room for smart technology in fabrics. And so I'm very interested to meet all of you, and particularly to hear your background, Charlie.
This is an area I'm also really interested in. I also, as well as my textile background, I am a palliative care nurse.
Okay.
So for me, I'd be really interested in working on clinical waste and sustainability and recycling or circularity within clinical waste, and particularly in terms of continence as well, because it causes a huge amount of wastage there. And I really think that there are possible solutions which need to, you know, be explored and developed around, that research could be put around. So that, I mean,
there's a lot of work being done in sensors, building sensors into garments.
Yes.
Detection leakage. So I'm just thinking, you know, of some of the work that you talked about, Stephen. But also there are other problems with incontinence. So, for example, filtering odours for people with fecal incontinence. Thinking about sort of fabric design, as well as just engineering very thin fabrics that do a very good job. They're very effective at containing leakage. And we're also very interested in sustainable options. I mean, in the incontinence world, an awful lot of single-use plastic is used. There's an awful lot of non-biodegradable materials used, and there's a lot of room for improvements in sustainable products. So we've got some projects which are working on reusable products, washable or cleanable products that can be reused multiple times to help with that. So I'm quite interested to talk to several of you after this, outside this group.
Can you give an idea about any of the sort of smart devices you say for detecting moisture, is it? And
yeah, moisture detection and using, I'm not an engineer, I don't know an awful lot about it, but my colleagues do. So using heat or moisture detection sensing technology to identify when leakage occurs. So for an example of when this might be useful is elderly, frail people in nursing care, many of whom will be continually wearing products. And so the challenge is, when do they leak? Disturbing them as little as possible, but catching the change point as close to the event of the leakage as possible. So that's particularly difficult with urine because it doesn't have the odour that feces does. You're more likely to pick it up with feces, but in both events you need to change that pad as quickly as possible to avoid incontinence-associated dermatitis. And just to say, we also work at the university with Dan Bader and Pete Worsley's Skin Health Group, So I don't know if you know those people, but they would be interested, I think, to talk to you. So yeah, so that's really the challenge. And we've used some sensor technology in one of our projects built into a urinal. So this is a urinal. We tried to develop an active urine collection system. So for people that don't know when they want to pee, or even if they do and they can't actually get to the toilet, they may be completely sedentary, and so they need to put a urinal in place to have their urine actively removed from their body and contained to such a time when somebody can empty the device. So we use sensor technology to try to design a urinal which would be the optimum size for a woman to use. So we've used it in that way. Sorry, I'm not being very articulate about that, but that's just an example of when we've used sensor technology in a urinal as opposed to a pad. We tried to build that into a pad, but it didn't really work terribly well. But there's lots of potential there, I think. Yeah.
Are these sort of smart pads, are they designed to be disposable, or does the smart functionality alter that in any way?
No, well, you want the product to be washable. So, designing something which is reusable, which has that technology in, would be an ultimate goal, because, throwing these pads away is not a good thing. They're full of super absorbent polymers, and they have they have non-biodegradable plastics on the back, the waterproof component. So in our designing work that we're doing of washable absorbents, we tend to separate out the absorbent function and the plastic, not just partly because of washing. Washing is a big problem with these products. They have to be very bulky at the moment to have that absorbent capacity to make them effective. But then they're very difficult to wash and dry. So we're doing a lot of work to separate out fabrics, the different components, to make them easier to handle. And interestingly, we're doing that in a project with the World Health Organization at the moment in low and middle income countries, where people typically use bits of toweling. In fact, interestingly, they use some of the components that we use for our new design, but just because that's what they've got bits of towel, they've got plastic bags that can be redesigned into something like a waterproof backed containment device. Yeah, so there's lots of scope for developing new products and taking better products to people worldwide.
I just wanted to weigh in there, Stephen. It's been, what, 2 years since we spoke to each other?
Well, it's when we started. We've spoken since then, but yes. Yeah.
Yes, it just sounds like millennia ago, isn't it, since we've had that kind of idea about. And I'm glad that you mentioned it in the talk. Sorry for I've put myself in the chat because I was a bit on a clinical call. I'm Ayman Al-Zatani. I'm a surgeon at the General Hospital. And back 2 years ago, I think we've had a mutual acquaintance, me and Stephen, about who talked about using his technology in a dressing, and it's been progressing slowly but surely, I would hope. So have you sort of had any questions on that? Sorry, because I missed the first part of the talk. Has any other people showed any interest in the project?
Not yet, not in the wound dressing point. No. So yeah. I've appointed someone that's just about to start who's actually going to work specifically on that now. So I've got a position, 2-year postdoctoral researcher working on the smart bandage specifically. So I really do hope this can go somewhere now.
Yes, because I think you are looking for somebody who can be sort of teed up for this project, and people have been sort of passing by and not, and now you have one tied to the sink, hopefully.
Yes, absolutely. Yes.
Very good. And do you think now it's worth having a chat with that person, sort of to see where the prototype can be developed?
Yeah. I mean, they start after Easter, but yeah, when they're in place and they've got their feet, they're settled in a bit, we should certainly involve them in the discussions and the meetings, etc. Yeah.
Yeah.
They have their background is from the technology side. They're completely unfamiliar with the application. So yeah.
Okay. Well, there's no reason why we can't in the sort of start with some dirty dressings or clean dressings or something which you can piggyback this on, like we did with Francis, way back. So they can sort of do some sort of dummy runs if needed, and then see how they can match up the technology with the currently used dressing we have. So for the sake of the audiences, wounds is one of the biggest things which we deal with in hospital. I'm a surgeon. I make a lot of them intentionally. So and one of the biggest problems we have is getting them to heal, and if they get infected, or preventing them from getting infected. But we also have wounds which are very common in the community. People with ulcers in their leg, with diabetic feet, and these require attention, and it can take months or years to look after those. And then pressure ulcers from people lying in bed in care homes. All these are counted as wounds, and these are areas where having some sort of a smart technology, which is what Stephen and his group is working on, can help us become more smarter, to quote a word from the name of the dressing, in managing those dressings. At the moment, it's very much clinical experience, people who have been working with these for years and years and years, who can interpret the wound and assess it and then make a decision about it. But having more information about the environment of the wound in a variety of aspects like pH, temperature, biological evidence of infection, evidence of healing, can help in guide the care of that wound from the various stages which it goes through. So this is just a background, and it's an interesting and exciting project, and I think it will make a big impact once it's implemented in a clinical setting, which we were hoping at some point to achieve. But so yes, just to throw something in the background there for the group to discuss.
Can I jump in and introduce myself, please? So I'm Nicola Simons, and Steve knows me because we've worked on a project together over in engineering. So I'm not a researcher, I work in enterprise. So I run an enterprise unit. The university has quite a few, especially over in engineering. So we work directly with industry and with other researchers on research grants. So I have staff who are available at the drop of the hat almost to work on project for a week or 2 weeks, a couple of hours, a couple of years, to support projects that involve material science, especially tribology. So I don't bring the smart side, that's definitely Stephen. I'm generally looking at, we'll have to call them dumb materials then, so just plain materials, but obviously the way you test a plain material could be the same way you test a smart material. So we can pull materials, push materials, rub materials, slide them, erode them. We also specialize in failure investigation. So we've worked on orthopedic implants that have been removed from people that have corroded, and being able to explain why, being able to do the material science, to be able to say that they used the wrong material, it was galvanic cell. So we're just here to support anybody at the university who needs to go forward in anything on material science, maybe a design question. I think I have been approached by somebody in the incontinence area before. There was more for mechanical devices to stop our male colleagues from accidentally wetting themselves, but that was more of a stopping it coming out than it was at catching it afterwards. But
yeah, that's one of our projects. We're working with Alex Dickinson on that.
Yeah, I think I was contacted about that to see if we could help with that project a while ago. But I was interested in all the reusable stuff. I mean, my kids are way past nappies now, being 9, 10, and 11. But I remember using the reusable bamboo inserts for nappies, and washing them out rather than getting through thousands of disposable nappies. So it's good to see that is moving a bit further forward. we still threw them away when it was the solid matter, but for urine, you know, it worked just fine on babies. So, you know, I can see the need for it for when we all get old. We've got to solve that problem, preferably before everybody in the room gets to the age where we need it, please. So that'll be great. But nice to see you all. So feel free to contact me if you have anything where we can help. But I just thought I'd introduce myself as I was here.
Thank you. Thanks.
I was just gonna put this in the chat, but you brought it up, Nicola, in your comments. Margaret, what are you doing on the sort of predictive side of sensing incontinence? And it seems like there'd be a lot you could do to identify issues before they happen.
Yes, I don't know personally. I'm not involved in any projects to do that, but I mean, toileting. Do you mean in terms of sensors? I don't know.
Yeah, sensors to sort of detect. I don't know. You could sort of detect maybe distension of the bladder or something like that.
Yeah, and I think there are projects actually happening. I think I can't give you any details, but I remember hearing about a project where there was some sort of device that floated in the bladder.
Okay.
Provided some sort of detection for bladder filling, so people could predict perhaps when they were likely to have an incontinence event. But not in terms of materials and sort of external sensors. I don't know of anything there. But interestingly, we're having a conference at the Institute for Mechanical Engineers. It's called Incontinency Engineering Challenge. Yeah. And I think this conference could be of interest to several of you. And so this brings together, it's a very multidisciplinary conference. It brings together product users, clinicians, industry, academics and scientists to try to find new solutions to incontinence management. It also includes sort of a bit about sort of surgical techniques as well, but we're mostly interested in containment and dealing with some of the problems such as gas and odour, that sort of thing. So it will be in November, and we do bring people from outside the incontinence world. Often people speak who have no knowledge at all of incontinence, but they're very involved in technology that can be applied. They may not even know it until they come. So we've had people who, we had an expert in origami, we've had an expert in biomimetics, we've had people, you know, who worked at NASA who are interested in handling fluids where there's no gravity. That sort of thing. That's the kind of approach of the conference. So I hope you won't mind that I can contact you outside this group and tell you a bit more and perhaps speak to the organizer, because I think, you know, some of the work that you're doing is very relevant and your interest over that.
Sounds really interesting. Do you know when is that event?
It's in November, but it's virtual. I think it's the 16th and 17th. I should know because I'm on the organising committee. But it's led by Alan Cottenden from UCL and Pete Colmer from Leeds. I don't know whether you know Pete. Anyhow, yeah, so I'll definitely let you know about that. In fact, I'll probably try to put the link up in the chat if I can manage that technology myself. Okay.
Yeah, that'd be good.
I'll do that now.
It'd be really interesting to see.
Yeah.
As it seems like the focus of a lot of this does seem to be on the sensing side. It seems like, or the sensing after an event side even. And it does seem like there aren't many products available for people to sort of prevent issues before they happen.
No.
It seems like a lot of, I don't know, it seems like a perfect place for innovation. I looked into like solutions for people with ileostomies, and it seems like most of what people have as an option is so sort of I don't know, it seems like it should be outdated. It's like the sort of simplest approach you could possibly take, to sort of cutting out someone's colon and putting a bag on top. And it seems like the perfect place for getting sensors in and trying to identify issues before they happen.
Well, there's obviously lots of room for innovation there, and all I can say is you need to come to the IMechE conference and and share in the thinking about this.
Yeah, because I think this stuff I'm doing, maybe you could do it on the like stretching side. If you could sense material stretching, I don't know how. I imagine it'd be a really noisy signal. It's probably difficult to do.
Yeah.
But just as an area, it seems really interesting. It would be really cool to see what people are up to.
Also, I'm thinking there's a lot of problems associated with catheters, indwelling urinary catheters, and blockage.
Okay.
So obviously catheter-associated urinary tract infection is a big deal. And as a lot of our work, we work with a microbiologist at NBIC who's very focused on biofilms and catheter blockage. But it may be useful to understand when there's bladder distension occurring, if there's blockage, but it's not detected through pain or sensation of distension. Maybe somebody that's got a spinal injury or something, got reduced sensation in their bladder. If you could detect some stretch of the bladder to enable you to prompt you to have a catheter change or to do some intervention to reduce that blockage before they get overflow leakage around the catheter or some sort of damage to the bladder which can't be corrected, some permanent damage to the bladder. So that would be an area for an application of this nature, I think. Yeah.
That's really interesting.
Seems like the bladder and bowel world there's lots of room for your technologies and your interests.
Right, yes. Does anybody else have any potential applications on it? We've been joined by Michael and Peter.
Yeah, sorry, I was just in another group, so I wanted to do too many things, but just keen to touch base here. So sorry if I missed the conversation earlier, but yeah, I think obviously it makes a lot of sense for me. Textiles, smart materials, and skin, huge potential application synergy there. So I just think it's, to some extent, if I talk about the clinical end of the problem, when we practice dermatology medicine, we rely on essentially 19th century really, or perhaps generously 20th century approaches where we kind of look, feel, and if we need to sample something, we actually cut into it and put the patient under an anesthetic of some sort, of local or whatever, and so I think that with modern technology we should probably be able to do better. And we can actually translate some of these things we're seeing with our eyes into numbers, and then be able to generate AI that can lead to better provision of dermatology care. Because the problem is it's such a pyramid. So the people trained to be dermatologists are so small in number, and yet the disease burden is so massive that we can't really deal with it properly. We need to automate it. So the only way to automate it is to put numbers on the thing. And that's why I really am interested in this whole concept of sensing and smart materials and things to try and move that forward. And I think going back to or sticking with the current system where we actually have to take whole lumps of skin off people to send it off to the lab to sample it, it just it's not a practical way forward for mass healthcare. And it isn't just a problem for first world countries, but obviously it's a massive problem. It's a global problem. Skin disease is a massive global problem. So it'd have a huge impact to develop these sorts of advances.
So from sort of like the engineering point of view, what is it about the skin that could be detected or monitored that would indicate a condition, for example? Is it something visual, an optical effect?
So yeah, absolutely. So obviously, when someone's skin gets inflamed, it does change color. There gets change in blood flow. There's a change in humidity or electrical impedance and water content. There's a change in inflammatory molecules. So cytokines, chemokines, all of these things can be detected. And in my view, there's a lot to play with, if you like. So as I think as I've made the point in another group, but the some proposal I've put to you is this idea of diagnosis. But actually, I don't know whether it surprised anyone, but the we're developing more and more complex treatments for skin disease, and obviously it's the severe end, but it's still pretty common because skin disease itself is so common, and so we're treating people with drugs that are now costing between 10 and 100,000 pounds a year for skin disease. So alongside the diagnosis, there's response to treatment, and predicting response to treatment is really, really important. So I've been approached by several big pharma companies who want to do better at our classification of severity of skin disease, and also predicting response and also measuring response. So because they have to make the health economic argument for their drugs. So there's a lot of sort of industry support for work in this area.
So that seems like an ideal opportunity, some sort of wearable sensing, long-term sensing.
Yeah, exactly. I think I heard as well people mentioning here that about sort of microbiological aspects and that sort of area. But I mean, obviously, the microbiome on skin is another big thing, and so measuring that in some way is hugely attractive. And any therapeutic approaches to modifying the microbiome by wearable materials is also very attractive. There have been some already. So there's sort of artificial silk impregnated with specific chemicals, materials that have been designed to, and the sort of USP is to modify the microbiome in skin. So people trying to do that. In clinical practice, they're not really that effective at the moment, but yeah, so there's aspects there as well in microbiome type related work.
Hi, Michael. Just to jump in, we have about a few minutes left before we need to join the main meeting.
Sorry, I don't want to take them all the time.
Just to let you know.
Yeah. I'll let someone else speak.
So does anyone else have any applications from the clinical side? Jenny, do you have the questions that were? I couldn't find a Google document with the questions on.
I certainly do. So one good question here is, what are the biggest unmet care needs in your area? I know, Michael, you just described for dermatology. If there's any other clinicians here.
Can I sort of like add the question in regarding adaptive clothing? Because I think this is a huge area that has massive potential for people with any cognitive or physical disability. And from the design, the fashion, and these people are especially those that are working and in jobs, because mostly at the moment the clothing available to them is casual wear, and they are wanting more fashion wear. They want more professional clothing to be able to work. And I think that there is huge potential from design, from the textile technology, and also from electronics and the science integration as well into the clothing, to predict, to deliver, to monitor as well. So I think this is, and I understand there's a lot of work going on in America and the US for this area, and there is huge budget. There's like $400 million that they have to work on this area in the US, but there's not an awful lot going on here in the UK. So that's my area that I want to put out there. Thank you.
So have we exhausted all the clinicians in the group? Is that in this What are there any other questions, Jenny, we could focus on?
I've got a quick question.
Sure.
If that's all right. In your UV bandages, what sensors have you got in there? Are you detecting anything like from that feedback? Like, are you sort of looking at how UV interacts with the wound and detecting that?
We're not monitoring the wound monitoring will be temperature and pH in the first instance. Okay. So I'm led to believe that they're sort of indicators of the wound health or the wound how it's responding to the treatment and and hopefully healing. So yeah, they're relatively easy for us to implement as well.
Okay.
Certainly temperature is really simple.
Yeah.
Yeah.
Yeah, I was wondering if you were doing any kind of spectral analysis. I don't know if you can do that. Is the UV just an output and then you're monitoring temperature and pH?
Yeah, exactly. So the UV, I guess we're working with people in chemistry who are doing a very clever bit where they're designing molecules that will go into the film, and the molecules are designed to emit light at a very specific wavelength.
Okay.
And they literally can't change from that. So it's fixed. So provided you engineer the molecule to the right wavelength, then it's just a case of controlling the dose, because obviously it's very important you don't damage healthy tissue.
Yeah.
And you can do that electronically by controlling the input power to the device. So there is electronics around it, but we don't monitor the actual the emission yet.
Yeah. Okay.
But that certainly could be done. That's not difficult. But it's kind of one step at a time. It's
Yeah, it makes sense. There's, I don't know, it seems like there are a lot of applications for that in incontinence stuff. But I don't know. I mean, I don't know how much data you'd get back from passing light into, or trying to get it in someone's bladder, maybe. Like, but I imagine you could maybe, if you had a strong enough light source, you could see differences with bladder filling up, or maybe like just electrical impedance across the bladder. Maybe you could tell differences if it's full or not.
There's some potentially very interesting technologies around, for example, RFID, where the response of the RFID, the antenna, effectively changes depending upon the properties of the material behind it, i.e. the body.
Oh, okay.
If there's a change in the dielectric properties as a result of a bladder filling up, and you monitor that, it changes the response of the antenna. And it's entirely non-contact, and it can be done, across a range of a few meters. I have no idea. I mean, the human body is mostly water anyway, so I don't know exactly. But it's RFID sensing is something that's really interesting from our point of view, because it's very easy to implement.
Yeah.
But how well it works for the particular sensing is something that we're not sure of. So we've just done studies on using it to detect water freezing. So, for example, if ice is forming on plane skins or whatever, so you're monitoring the formation of ice. So it changes the dielectric properties, and you can sense this remotely. So I do wonder how much the application of that could be for these sorts of applications.
Does your group put much energy into that side of it? Like, do you just develop the technology and then pass it off to other people that would test it with patients usually?
So I'm really lucky. I've just been awarded a 10-year fellowship, effectively, from the Royal Academy of Engineering. It's an emerging technology chair, and so it really is. I'm really interested in actually getting it out of the lab and into the application domain. It's something I want to focus on a lot more over the next 10 years, and having a 10-year opportunity to do that is, it's fantastic. It's very rare. So yeah, I'm very keen on getting just beyond the fundamentals and looking at the applications in more detail, and maybe potentially handing over to guys like yourself at Future Worlds to exploit. Is exactly what we should be doing.
Yeah. Well, there's a load of students that are interested in it I've spoken to, so I'm sure you'll find people.
Yeah.
I think that's one of the things, or it's one of the things that I found being an undergrad. And it seems like a lot of people do, that you develop cool technology and you're like interacting with all these research groups that are working at the cutting edge, but you don't really get a chance to sort of bridge that gap between being in the lab and actually interacting with people, but using that technology to benefit people. And I think there is a growing appetite for people to get into that stage. So yeah, I'm sure there'll be loads of interest if you speak to people at Future Worlds. I'll send one over to you if I find them.
Yeah. I think it is having these really good applications that a key application to address, and then and I'm personally more than willing for people to run with these things and to exploit them when it gets to a suitable point. Yeah.
I was just thinking, have we got a minute still? I was just thinking about our penile compression device. I don't think I've mentioned it in the breakout room, but also known as a clamp. So this is for men with mainly men with stress urinary incontinence that have their radical prostatectomy, and who are all living now, but living a lot of them with incontinence. And so this is a bit like, just think a very simple freezer clip as a starting point. There are lots of clamps available worldwide. Most of them don't work very well. And so with Alex Dickinson, I expect you all know, we've started developing a prototype improved clamp. And so, of course, there's a problem with pressure and blood flow. And we've done a lot of work with testing with our prototype and with existing devices with Dan Bader and Pete Worsley. But what I'm thinking is it would be really nice to have a clamp, because the penile geometry changes, as you all know, during the day when you might be wearing this device. So the pressure will change throughout the wear time. And so I'm wondering if there was some way that you could alert the man, other than discomfort. Some men can tolerate them much more than others. Maybe they're not, we don't recommend them for people unless they've got good genital sensation, but maybe they're using them inappropriately, or for some reason they can't detect that there's a dangerous pressure change happening. Could you build something into a clamp, a penile clamp, that will be useful, that could alert men to a change in blood flow, pressure, change in blood flow, that would trigger them to remove the clamp? Because they're only supposed to keep them on for short periods of time. That's what we recommend, but some men keep them on for a long time.
That sounds like something that should be relatively straightforward. After all, essentially you're sensing strain within the ring, I guess. I can't really visualize what it is, but essentially sensing strain is normally a very straightforward thing to do. To be built into the device.
I hadn't actually thought about that until just now.
Yeah.
I thought you could adaptively change the strain as well. I don't know how. It seems like a really cool technical problem to like detect the strain and adjust for it. Because I can imagine you could do that without the person needing to take it off if it was getting too tight.
So I think we've tried to do that within the design to a certain extent, because it's kind of a spring design within it.
Okay.
But maybe that could be taken further. Maybe something else could be added that would make it more sensitive and safer. Ultimately, that's what it's about: safety.
Sorry to interrupt, Margaret, but I think the main meeting, we're going to go back to the main meeting now. So we'll end this breakout room, but thank you.
Thanks, Jenny. Thanks, everybody. Very interesting.
Thank you. Very good. Yeah.
Thank you.
Thanks.